This morning we're going to talk about SQL injection, and we're going to do the very basics. Now, there's a couple things I want to just briefly say. The first one is that you should not, I know in an open source world that we live in, everybody is obsessed with telling everyone else how they do things. And I'm going to be one of the few voices that say you actually should not tell people what you're doing all the time with SQL injection. And the reason is, if you've ever read the book The Art of War by Sun Tzu, he talks about when you're in a contest, and remember, Sun Tzu's writing about war, so you're in this contest, the unscrutable and the unpredictable win. The predictable and the scrutable basically lose. In other words, if you announce your strategy to the world, you're not going to walk away winning. You're going to end up losing. And that's just one of those things. When you're in a contest and you apply that to a contest, that book to a contest, in other words, you don't apply it to other things. And hacking and dynamic SQL and SQL injection, those are examples of where you're going to enter a contest. If you're going to put anything out there for people to look at, you open yourself up to hackers. Now, for instance, a lot of my databases that I have are for my view only. Like, for instance, all my Twitter data, as a case in point, nobody gets to look at that. Although I market to clients and I'll print reports for them, they never see the data in the database. Nobody does. It's not client-facing. And same thing with my stock data. It's not client-facing. So I can write my queries the way that I want, and I don't have to worry about dynamic SQL because only I could hack into my databases. And I have no incentive to do that. But if you make something client-facing, you have to consider the fact that there can be hackers. And again, I would not announce to the world your counter strategies. I know we live in this open source world and everybody should know everything that we're doing. And we love to post things on Facebook and Twitter. But at the end of the day, there's a lot of value in privacy. Hackers should not know what you're up to. They just shouldn't. Your strategies to counteract them should not be out there. So I'm going to use very, very, very simple examples today. And we're going to go over this. But to keep that in mind, the way you're going to counteract hackers is not going to be something you're going to announce to the world. Do not post your code on GitHub. Do not post your code. Do not write articles about it. Simply put, let it be something that you're silent on. Think of it like a chess match. Before going into a chess match, would you announce to your opponent your entire approach? And there's a high probability that you wouldn't. For instance, I know a little tic-tac-toe strategy that I can beat pretty much anyone in tic-tac-toe, but I'm not going to go announce it to the world. Because as soon as I play tic-tac-toe against someone else, they'll know exactly what I'm going to do, and they'll know exactly how to beat me. So, it's the same thing with hackers. This is one of these things where privacy is good. So let's use some simple examples. What is SQL injection? So let's look at our table, drop me now. It's kind of a bizarre name for a table. But it has three values, right? We have A, B, and C. Okay, and let's suppose that we create a stored procedure, and what we want our stored procedure to do is we want our stored procedure to basically allow the users to select any value in the table. So you'll notice what it's going to do is it's going to execute this select statement. Select star from drop me now where ID equals, and this is this S string. Now I want you guys to pause here. I'm going to create this procedure. I want you to pause the video here and think about right off the bat something should be saying there's something wrong, and I'll give you a hint. I'm not even talking about this line. There's already something wrong with this stored procedure based on what we saw in terms of our values in our table. But you should see something wrong above this line. So pause the video and see if you can see it. Okay, so let's look at our values in our table, right? A, B, C. They're one varchar. And if you'll notice in the table, it's the ID is varchar2. But right off the bat, our procedure is allowing someone to pass in a varchar that's 300. That should be a red flag. There's no data validation either. But we're allowing someone to pass in a varchar 300. If the highest value in your table is 2, there should never be a reason that you should allow someone to pass in a varchar of 300. Never at all. So, but we're using this as an example, and one of the ways to counteract SQL injection people will talk about is data validation. And again, that goes to you know what to do. Now it's how you want to validate your data. Okay, so let's suppose that we go ahead and, by the way, I tested this in 2012. So it works in 2012, but I actually don't know if these are going to work in 2008 R2, because this is 2008 R2. So you'll notice that if we look at for value in the table where A, we get back A. Okay? So everything works if we were a user and we were actually trying to see if there was a value of A in the table. Now, in this string, this is where we're going to use SQL injection. So what we're going to do here is we're going to look for A, but you'll notice we have 3 apostrophes and we have 4 apostrophes. So what our hacker has done is they have, instead of looking for A, they have looked for A, then they've put an extra apostrophe here, a semicolon, and now they're selecting from the table where 1 equals 1, which is everything, right? Because 1 always equals 1. And then they're printing, I control the database. You know, but like a hacker, they can't spell. And you'll see, I controls the database, and they got everything, right? So that is an example of SQL injection. Basically, this code here, it's a very, like I said, very, very simple example. But this code here allows users to get access to everything in the database because of the way it's coded. And if you think about it, it's even if you think, and I want to use this example big time because you would not believe how many times people have told me, oh no, stored procedures are perfectly immune from SQL injection. No, they're not. You can get access to the database with stored procedures. And you could even think that this stored procedure has a parameter, right? It's S, but yet you'll look at it, it has that variable, and you can still get access. You also see this in C# code. For instance, in C# code, they'll have a direct query, and it selects star from table where, and then they have, what is it, the quotation marks, and then they have one of these apostrophes, and then plus, and then convert to string textbox.text, and then they end it, and it's like that person has access to everything if they entered some other string. It's the worst thing you could do. I've seen that a lot in C#. And again, you'd be surprised. Some of these big companies, you'd be surprised how many of them are open to SQL injection. It's like people don't know what it is. They don't read more about it. And there's a ton all over the internet with more details about it. Okay, so now we're going to look at another example. Okay, this is... Okay. One second. This is where I have 2 different computers. And in our first example, you will remember that, as a case in point, one second. You'll remember in our first example, what we had in our first example was, hold on, we basically allowed users to pass in something directly, right? We didn't allow users to, we didn't actually validate the data at all. And for instance, again, the very, very first thing that's wrong with this, and we're using 300 here too, but I mean the very, very first thing that's wrong with this is the fact that it's 300. It's just ridiculous. I don't think that I would never use something, if the maximum value is one thing, I would never use something greater than that maximum value. And that's something to keep in mind in your database. Unless your data are going to grow to be huge, there is absolutely no reason to do what most people go about doing as far as giving users a lot more entries to make. You'd rather the error be thrown off the fact that they've entered something too long. So we're going to create a procedure. This time we're going to use dynamic SQL, just like the other one. The other one, remember, is a dynamic SQL example. So we're declaring SQL, we're declaring the variables, and our SQL, and again, you can see tons of former videos where I've done this, but we use dynamic SQL, and in our dynamic SQL, we're actually now using a parameter within the dynamic SQL, which is S. Then we're setting the variable S to varchar. We're executing SQL, and again, this is one of these where people think that this is immune to dynamic SQL, and it's not. We're executing our command, we're executing it with the variables, and then we're saying that S equals S. Okay, and I don't think I've created this one. Okay, I guess I have. All right. So remember, in the former one, this is the same exact code, right? We're just seeing if we can select something. In the former one, we have the A and then select star from drop me where 1 equals 1, and then I control the database, which we don't want. And the former one didn't prevent that. You'll notice when we execute this one, again, in the first one, we get everything, right? We get what we want. Users have control of what they want. But when we execute this next one, notice what happens. Nothing. That's very important. And when a user executes the code correctly, they get what they need. When a user does not execute the code correctly, they do not get to control the database, they don't get all the values, and they don't even get A. Now, again, right off the bat, if you look at this, one of the things that I'll show you, and I will go back to alter here, as just an example of data validation. So we could do declare, and we could do declare L, and we can call that L is an int, and we could set L equal to the len of S. And so len is for those of you that don't know, len basically counts the number of characters in a string. Okay, so we're going to declare len as S. And again, don't think this is going to stop SQL injection either. This is a very, very oversimplified example of catching things in a string. Okay, and so what we're going to do is we're going to say if L is greater than 2, begin, end, else, begin, and then we're going to do, hold on, tab, end. Enter. One second. Okay. All right. Begin. So what I want to do now is I want to print the string plus there. And while we're at it, we'll go ahead and we'll select L. Right off the bat, I can't remember if this works or not. I did something very similar to this the other day, just for fun. And I'm pretty sure it was similar to that. So what we're doing now is we're declaring L as an int. We're counting the number of characters in S, which the user is passing. If it's greater than 2, because remember our table is a varchar of 2, right? We're actually going to select the number of characters it is. We're going to print the string and then haha morons, and then we're going to we're not going to execute the rest of it. The reason why I use this as an example, so that has been altered, right? I think so. But the reason why I use this as an example is, so for instance, in some cases what you want to do is that once the data is validated, if the data are not validated and it's obvious that someone else is doing something that they shouldn't be doing, you actually can deny permissions, right? You can sit there and say, oh, this person is trying to do something that they shouldn't be doing. Now we're going to take that username, especially if it's a user in your database, we're going to take that username and deny permissions. So you'll see it returned 72 because what it did, it validated the data and it said, whoa, that's over 2. It selected it, and then if we look at the message, it actually printed it back at them, and it said, print, I control the database, haha, morons. And so the thing is that, yeah, go ahead and drop it now. But the thing is what it did is it validated that data, and since the data are invalid, then it went ahead and spit out the error. And again, this could be something where, what is this? You could deny permissions right here. So as a case in point, one example of this, and again, these are simple examples. Do not in any way, shape, or form take this to be, oh, okay, now I have everything solved. But as a case in point of this, hackers will generally try and then try and then try and then try. They'll keep trying. And one of the things that you can do is you can measure, let's say if you have a username or something similar to that, you can actually detect how many times or how many attempts there are in a certain amount of time or over a certain number of days or from a certain IP address or all that other stuff. And then If there is that, then you can block those users or whatnot. So there's all kinds of counter strategies to this. But I will say that the key to preventing SQL injection is, number one, validating your data. Number two, and I cannot stress this enough, the most obvious error is that. Don't ever give your users, if the maximum string in your database is 30, don't give them more than 30. That really forces them to be limited as to what they can do. And then validate that it's a valid string. And it's better to do that on the front end than the back end per se, but you can do it on the back end as well. Validate that data, and then, as I always say, parameterize your queries. Make sure that there's parameters. Make it very difficult. And then finally, your upper level strategies for dealing with SQL injection, those are things that you don't share. You don't put them on GitHub. You don't talk to the community. You don't. Because it's like going into a chess match. I cannot stress this enough. If you go into a chess match and you sit there and you say, I'm going to use my rooks to completely take out your king, well, the first thing that your opponent's going to do is go after your rooks. I mean, you don't announce your strategy to your opponent. That's not what you do. And in the world of open source and share everything and share all your information, I know that's a counter strategy, but it's one of those things where Sun Tzu, his book has held the test of time. There's a lot of value in silence. Be clever, but don't share it.